So today we are going to start organic chemistry, that is 12th class portion, and in organic chemistry we are going to start with the first chapter, that is alkyl halides. So if you go for alkyl halides, that is, you can just alkyl halides. When you say alkyl halides, you can also add one more unit for this, that is aryl halides. So if you go to the general formula of alkyl halides, if you take general formula, you can take Rx. If you take aryl halides, general formula, you can take that is C6H5 of X, or simply you can say AR means aryl halides, you can take it as AR of X. Here AR represents the phenyl group, and here R represents the alkyl group. So apart from this alkyl and aryl halides, we can also take, that is vinyl halides. When you take vinyl halides, if you take vinyl group is C2H3. So because it is C2H3, we can take the general formula for this vinyl halide. We can take the general formula as that is CH2 double bond CH single bond of X. So this CH2 double bond of CH is the vinyl group and X is the halide, so vinyl halide. Also we can take, that is allylic halides. So if you go for allylic halides, general formula, this here, if you take allylic group is C3H5 single bond. So because it is C3H5, you can take this as CH2 double bond CH single bond CH2 of X. This is allylic group. And apart from this, you can go for further classification, like I'm going to add one more, that is, we can call this as benzylic halides. If you take, you can just directly take the general formula as C6H5 single bond CH2 of X. This is benzylic halide. So that means from here you can add some examples we can add. And when you go for alkyl halides, so when we are going for alkyl halides, we can take number of examples. That is, I can just take it like this. The simplest alkyl halide is methyl chloride. You can take CH3 CH2 Cl. You can also take CH3 single bond CHCl. You can take carbons satisfying the tetravalency, chlorine group CH3 and CH3. So what you are noticing in these three examples, in these four examples, what we are noticing is, here the first one is, if you want to just show the common name, if you want to write the common name, here in terms of common name, you can simply write it as there is only one carbon and one chlorine group is there. One carbon, one chlorine group is there. So we can simply say methyl chloride. Common name is methyl chloride. Indirectly we are speaking about the nomenclature of the alkyl halides, methyl chloride. But if you want to write the IUPAC name, this is 1-chloromethane. Here, because we have two carbons, we can call it as ethyl chloride. This is 1-chloromethane. ethane, 1 chloroethane. Here if you go for here, because we have 3 carbons and what the chloro group is attached to in between carbon, so we can just take this as, actually if you want to take a common name for this compound, you can just write it as, because there is a branch here, so isopropyl chloride, or you can simply take this as 2-chloropropane. This is something like, it's this is a tertiary carbon, and the chloro group is attached to the tertiary carbon. So we have 4 carbons here, that is 1, 2, 3 and 4. So it's a tertiary butyl group. So therefore we can simply, if you want to write the common name or the trivial name for this compound, you can simply say tertiary. 3 degrees stands for tertiary butyl chloride. Tertiary butyl chloride, and if you want to write the IUPAC name, that is 2-methyl, that is 2-methyl butane is the IUPAC name. So these are all technical names, they are all IUPAC names. IUPAC names, these are some of the IUPAC names where we can write for the different alkyl halides. So let's continue with the nomenclature of the alkyl halides. So when you go for the nomenclature of alkyl halides, indirectly nomenclature of alkyl and aryl halides nomenclature. So in this we can just take some examples I would like to give you. This is benzene ring with the chlorobenzene. This is benzyl chloride. This is chlorobenzene. This is benzyl chloride. We are using this word benzyl because benzene ring along with the CH2 group, we just name it as benzyl, and the chlorine is attached to this benzyl chloride. Likewise, you can also take that is, say for example, if for the carbon, if it is attached with 2 chlorines, it is benzal. Chloride. The word benzal represents that benzene ring. Now this is more or less like a secondary carbon, and this is more or less like a primary carbon. Here the CH2 group is termed as a primary carbon and CH group is termed as a secondary carbon. Benzene ring with secondary carbon attached with the secondary carbon and substituted with the 2 chlorines, we call it as benzal chloride, and this is benzyl chloride. In the next case, we can just take this as now if you are attaching, if 3 chlorines are bonded for the carbon, then that is going to become the tertiary carbon. This is tertiary carbon, secondary, and this is primary. So we can call this as benzo chloride. So more or less, like, we are not particularly bothered about writing the IUPAC names, we are just writing the common names of the 3 compounds. If at all, if you want to write the IUPAC name, then you can just write it as you can just take it as 1 chloro, 1 phenyl methane is the IUPAC name, and here also we can do the same thing. This is 1, 1 dichloro, 1 phenyl methane. In other words, here benzene ring is acting as substituent in all the 3 cases, and here you can take 1, 1 trichloro, 1 phenyl 1-phenyl methane. 1-phenyl methane. So this is something about the nomenclature of the benzene compound, and if you want you can just add few more, like suppose I am just taking it like this. Sometimes two chloro groups, different substituents are there. The compound is like this, benzene ring with the two different groups of attachment, one methyl group and one chloro group. Then we can use the alphabetical order. In fact, this is a parent derivative. We can just take this as C for chloro and 2 for M for methyl. So what I can say is like orthochloro. The common name is orthochlorotoluene. Orthochlorotoluene, and IUPAC name if you want to write, you can just take this as 2-chloro-methylbenzene. Benzene. And if you add, sometimes what is interesting here is, sometimes suppose you are taking all this comes under the aromatic compounds, and if you go for benzene ring, you know pretty well that if you go for benzene ring, if suppose if X is the halide, and it has this is, say this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6 on the benzene ring. So what we are noticing is, always when you are going to analyze the benzene ring, this is nothing but this is halobenzene. Say this is halobenzene. In this halobenzene, what you are noticing is, you have to take some conditions here. Actually, 1 with respect to 2 is always called as ortho. 1 with respect to 3 is meta. 1 with respect to 4 is para. Also, 1 with respect to 6 is also ortho. So that means we can make one analysis in the benzene ring saying that 1, 2, 1, 2 and 1, 6 are ortho cases, and 1, 3 is a meta case, and 1, 4 is para case. You have only one meta position, that is 1, 3, and you have one para position, that is 1, 4, but you have two ortho positions at 1, 2 and 1, 6. So suppose, for example, keeping this into our mind, suppose if I am taking here a benzene ring, say I am just taking benzene ring and I am just taking one chloro group, I can say that this is ortho dichlorobenzene. Ortho, at ortho position chloro group is there, so ortho dichlorobenzene. Next it comes para dichloro. That is meta dichloro benzene, and so on. Benzene and so on. So this is the simple nomenclature of the aryl halides. All this comes under the aryl halides. Aryl halides nomenclature. Now if we go for the alkyl halides, we have some important examples for alkyl halides also. We will finish off that examples also in the form of nomenclature, and we will study some more examples. So here look at this small exercise where we are going to write the IUPAC names for the given structural compounds of the formulae. So what we need to notice here is, one thing what we have to notice here is, in this first example there is a competition between the functional group. Here this is the functional group double bond, and here this is the substituent. The analysis, when you are writing the IUPAC name for a given alkyl halide, one thing what you have to notice is, you have to observe the structure very carefully. When you are observing the structure, you should also find which is functional group and which is the substituent. Once if you identify both the functional group as well as the substituent, then between the functional group and the substituent, the functional group should be given the first priority and the substituent should be given the second priority. So if you carefully analyze this structure, the longest chain possible is from the functional group. The longest chain possible is, that is, here you are finding one carbon, and here you are finding one carbon, and here also you are finding one carbon. If you are going from, I am coming from left to right, when I am coming from left to right 1, 2, 3, that means the substituent is occupying the third position and the functional group is occupying the the functional group is occupying the first position and the substituent is occupying the third position. That means you are giving first priority for the functional group. Of course, there is one more substituent in the form of chain, because this particular methyl group is not a part of chain. So this methyl group also can be considered as a substituent only. So what I am doing is, the best thing, the wise decision what we can do is, we can just take the longest chain from left to right. So here I am marking as 1, and here I am marking as 2, and here I am marking as 3, because here there is one hidden carbon. And no doubt here bromo group is a substituent, as well the methyl group also has become the substituent. So because when you are selecting the longest chain, in the longest chain first you have to highlight the substituents, and in that substituents you have to follow the alphabetical order. This is bromo group and this is methyl group. Bromo B, methyl M. So first give preference for the bromo group. I'll just say this as 3 bromo. Then on the second position methyl group is also present, so I'll take it as 2 methyl. The longest chain is 3, so the root word is prop. Number of carbons represents root word is prop, and the double bond is located immediately after the first carbon. So I can simply say 3 bromo 2 methyl prop 1 ene is the IUPAC name for this given compound. Likewise, if you're going for the second structure, here also the same thing, but one thing, be careful here, the longest chain is going to extend from the maximum possible distance. So what I'm doing here is, this is substituent. Bromo group is a better substituent compared to the methyl group. Suppose if I'm going from the bromo group itself, 1 2 3 4, if I go from right to left, if I'm going from right to left, just I'm creating a dotted line here. If I'm going from right to left in this direction, what you're noticing is you're giving the first priority for the substituent, as well as the priority is also given for the functional group. This is the functional group. But whether you're coming from the right to left direction, you're coming from right to left or from left to right, that doesn't make any difference here. So what I'm doing here is, I'm going with the right to left direction, because here when we are going from right to left, you are not only covering the substituent, you are not only including the substituent, but you are also making sure that the position of the double bond in the form of functional group is remaining unchanged. So therefore this I am going to take 1, and this I am going to take 2, and this I am going to take 3, and this I am going to take 4. The longest possible chain is 4, and in the meantime it is very clear that here the bromo group is going to become the substituent, and methyl group, because it is not a part of chain, this methyl group is also going to become a substituent. So now what I'm going to do is, bromo starts with B, methyl starts with M. So I can just take this as 1 bromo 2 methyl, 1 bromo 2 methyl. The longest chain is 4, but the double bond is located after the second carbon. Longest chain, because it is 4, take the root word first, bit safe side. Double bond is located after the second carbon, so use a hyphen. 2 ene is the IUPAC name. 1 bromo 2 methyl bit 2 ene is the IUPAC name. Look at this. This is much more simplest example. If you take the third one, it is quite an easiest example as far as I'm concerned. Here this is double bond functional group, and this is a substituent. So you just go for the longest possible chain. You have to take the double bond functional group into consideration, and you should also consider the substituent. So the best possible thing what you can do is, you can't just simply take like this. If you're going like this, it is wrong, because you are completely ignoring the substituent. But if you're going like this straight, this is correct, because you are including the substituent, and also you are including the functional group. This is the functional group double bond, and this is the substituent. So going straight and selecting the longest possible chain is now taken into account with both the substituent as well as the functional group. So the best thing what I can do here is, because I am including the functional group, and functional group is given the first priority, this is the first carbon, this is second, and this is the third carbon. So therefore now what I am going to do here is, this methyl group in the longest chain is no more a part of the longest chain, so this is also going to become a substituent. So therefore now if I want to write the IUPAC name for this particular case, that is, the longest chain is 3, but at the third carbon the bromo group is substituted, which is substituent. So therefore 3 bromo, then longest chain is 3, at the third position substituent bromo group is there, longest chain is 3. So that is, and at the second position you have methyl group. So 2 methyl 2-methyl. Double bond is immediately after the first carbon, so we can simply say prop 1-ene is the IUPAC name for this given compound. This is the third example, and if you go for the fourth example for writing the IUPAC name, here also the same thing, almost the same kind of analysis what we made for the first and second examples. Here also bromo group is going to become the substituent definitely, and here going from right to left will be the correct decision. We can go from right to left, because when you're going from right to left, you are including the substituent into consideration, and double bond also is taken into account, and the position of the double bond will remain unchanged. But if you're going from left to right, you are seeing that the substituent position will be 1, 2, 3, 4th position will come. But if you go from right to left, I mean, I'm just using a dotted line here. If you're going in this direction, that is from right to left, you're including the substituent in the lowest position, and the position of the double bond also remains unchanged. So the best thing what we can do is, yes, highlight the substituent first. So this is, I can take it as 1 bromo. The position of the double bond is remaining unchanged when you're going from right to left, so therefore cast the longest possible chain. So this is 1, this is 2, this is 3, and this is 4. So the 4 carbons, root word is but, so I can simply say but. The position of the double bond is after the second carbon, so but 2-ene is the IUPAC name. 1 bromo but 2-ene is the IUPAC name of the given compound. So next part of the discussion is, let us go with the poly halogen derivatives. We go for polyhalogen derivatives, that is dihaloalkanes, then you can take trihaloalkanes, then gem dihalides, vicinal dihalides. Suppose if you go for dihalogen alkanes, for example, go for dihalogen alkanes. Here you can take okay, suppose if you're taking dihalogen alkanes, if you take, then here I can take CH2 of X, single bond, CH2 of X. These are dihalogen derivatives. In the place of X, we can just take one example here outright, that is CH2 single bond chloro group, CH2 single bond chloro group. This is 1, 2, because there are two halogens substituted on two different carbons. Two halogens substituted on two different carbons, we call them as dihalogen derivatives or dihalides. We can simply say dihalides. So if you say dihalides, this is, if you want to write the IUPAC name, this is 1 and this is 2. So 1, 2 dichloro ethane is the IUPAC name. And if you want to go for trihalogen derivatives, go for trihalogen, that is B. Trihalogen derivatives, you can just take, suppose I am just taking trihalogen derivatives, I am just taking one small question, number of positional isomers obtained for C3H5Cl3. If you are given a compound, say C3H5Cl3, molecular formula of the compound is C3H5Cl3, and here we have three halogens, three halides are there, three chloro groups are there, three halides. So what we can do is, the answer for this question is, we can obtain 5 different positional isomers. So what is the technique involved in this question? So here we can applying skeleton method, so because there are 3 carbons, so here I can just take it here as that is first carbon, second carbon, third carbon. I am substituting all the 3 chloro groups on the same carbon. This is first isomer. Then in the second structure, 1, 2, 3, 2 chlorines on the first carbon and 1 chlorine on the second carbon. This is 1, this is 2. Then the third structure, again take 3 carbons, again take 3 carbons, 1 chlorine on the first carbon, 1 chlorine on the second carbon, 1 chlorine on the third carbon. Then we can take fourth structure, 2 chlorines on the first carbon and 1 chlorine on the third carbon. Fifth structure, 2 chlorines on the middle carbon and 1 chlorine on the first carbon. So here I repeat, applying the skeleton method for the given molecular formula of the compound. These are the different skeleton methods which we are applying for the different structural formula of the compound. So what I am noticing here is, what we could notice here is, in the first case we are trying to attach all the 3 chlorines for the first carbon. Just what you have to do is, you have to satisfy the tetravalences of all the carbons. So if you go for this particular carbon, there is only one bond is there, one covalent bond is there. So you have to satisfy the rest of the 3 valences for the carbon. So that 3 valences, what you could do here is attach one hydrogen, single bond, carbon single bond hydrogen and carbon single bond hydrogen. 2 bonds are there. So single bond hydrogen, single bond hydrogen. So this is one structure. Then if you go for the second case, here only one bond is there, again single bond hydrogen, single bond hydrogen, single bond hydrogen. 3 bonds attach one hydrogen. 3 bonds again attach one hydrogen. This is one more structure. Third case, 2 bonds, so attach 2 hydrogens. 3 bonds attach 1 hydrogen. 2 bonds again attach 2 more hydrogens. So here again, here 2 bonds, so attach 1 more hydrogen, 2 bonds, hydrogen and hydrogen. So again 3 bonds, single bond hydrogen. If you go for the next structure, here single bond hydrogen, single bond hydrogen, single bond hydrogen, all 4 bonds, single bond hydrogen and single bond hydrogen. This is one structure. So what we can do here is we can even write the IUPAC names also. That is, we can just take this as 1, 1 trichloropropane. Second one, 1, 1, 2 trichloropropane. Again 1, 2, 3 trichloropropane. Again here on this particular carbon there are 2 chlorines, and here on this particular carbon there is only 1 chlorine. So you have to give priority for that carbon wherein which it is having maximum number of substituents being substituted on that particular carbon. So here if you go for this particular carbon, here you are finding that there are 2 substituents substituted on this carbon. Here for this carbon there is only 1 chlorine which is being substituted. So what I am going to do is, I will select that carbon which is being substituted with maximum number of chloro groups. So what I am going to do here is, this is 1, this is 2 and this is 3. So I can just write the IUPAC name for this 4th case of the compound. Here I am writing here for the 4th case, that is 1, 1, 3 trichloropropane. Last case if you take, yes, we can see middle carbon 2 chloro groups and first carbon 1 chloro group. So 1, 2, 2 trichloropropane. is the IUPAC name for this given compounds. So the next part of the discussion here is we have completed the examples for dihaloalkanes or dihalides, and trihaloalkanes also we have completed. Now we'll go for the gem dihalides and vicinal dihalides. If you go for gem dihalides, it's very simple to understand. Take a particular carbon chain, and if for single carbon, if more than one halide is attached, you can see that both the halogens are bonded to the same carbon. What you need to understand here is the word gem indicates that the two halo groups are bonded on the same carbon. This is a gem dihalide. If you go for vicinal dihalide, this is on two different carbons, CH2 single bond, CH2 single bond halide, and again single bond halide. So that means here what you are noticing is the two halo groups are attached on two different carbons. That is vicinal dihalide. And in vicinal dihalide, you are finding that two carbons are there, and for two carbons symmetrically, two halides are bonded. So we can call this as vicinal dihalide. And in the gem dihalide, the two halides are on the same carbon. So let us take some examples. Proportionately, let us take some examples here. Here I can take CH3 single bond CH. In the place of halo groups, you can substitute any halogen. You can take bromo group and again bromo group. This is simply we can say this is 1, 1, there are two bromines on the same carbon. That's why this particular carbon has to be highlighted two times. So 1, 1 dibromo, that is ethane, is the IUPAC name, or we can simply say ethylidene bromide, common name, ethylidene bromide. In the case of vicinal dihalide, if you take an example for vicinal dihalide, we can just take, that is CH2 single bond bromo group, again single bond, and again one more bromo group. So here we can just take this as, because two bromo groups are substituted on two different carbons, so we can just take here, that is 1, 2 dibromo, 1, 2 dibromo ethane. 1, 2 dibromoethane is the IUPAC name for this given compound. So here we have finished the gem dihalide and also the vicinal dihalide. So now if you go for isomerism, next part of the discussion, isomerism in alkyl halides, usually alkyl halides generally they show isomerism. Usually they show two types of isomerisms, that is positional isomerism and also chain isomerism. So for chain isomerism, the minimum number of carbons required to show the chain isomerism in alkyl halides, the minimum number of carbons are 4, and for positional isomerism, minimum number of carbons required are 2, where n represents the number of carbons. So suppose for example I am going with the positional isomerism. Suppose if I am taking C2H4Cl2, it can give two positional isomers. One is gem dihalide and the other one is vicinal dihalide. Same example, whatever we have taken earlier, the same example we are taking here. That is CH3 single bond CHCl and again CHCl. They are positional isomers because both the chlorines are substituted or bonded on the same carbon. Vicinal dihalide, CH2 single bond CH2, again one chloro group and one chloro group. Next, if you take positional isomerism, if you want, you can just take one more example, that is C3H6 Cl2. If you take, I think we can get two isomers, CH3 single bond CH2 Cl, that is C3H7Cl, we can take C3H7Cl. So here what you are noticing is here what you're noticing is the chloro group is on the first carbon, so 1 2 3, 1 chloropropane. This is 1 chloropropane, 1 chloropropane. Again, if you take the next case, CH3 single bond CH, again CH3, take one more chloro group. This is 1 2 3. We can take this as 2 chloropropane, 2 chloropropane. That means now the chloro group is on the second carbon. Of course, you can also call this as isopropyl chloride. Isopropyl chloride is the common name, and 2 chloropropane is the IUPAC name for the given compound. So let us try to understand the positional isomerism in alkyl halides by taking one sample illustrative question. One question I am going to create on the spot. Total number of positional isomers possible for C4H9Cl and C6H4Cl2. So these are the two compounds in which we want to create positional isomers. So I am going with the C4H9, first one. C4H9Cl is the given compound. Then I am going to use one technique called bond line representation technique, because the number of carbons are 4 here. So what I am going to do here is, that is 1 2 3 and 4. So what I would like to do here is, I am going to take enough number of chances for showing the different positional isomerism. So here I am going to attach one chlorine here. This is first positional isomer of C4H9Cl. Second one is again 1 2 3 4. Okay, one chloro group I am substituting over here. This is second case. If you go for third, if you go into third, then I am going to create one branch. I am going to create one branch like this: 1 2 3 and 4. So here I am attaching one chloro group here. This is 3, and another one is again 1 2 3 and 4, because there is one more hydrogen is there which is replaceable, so I am going to place one chloro group here. Now what if fifth one? I think fifth one I can take it like this, again 1 2 3 and 4. So if I am going to place one chloro group over here, I think we are going to get 5 different positional isomers. Let us satisfy the tetravalency in all these 3 cases, because already one bond is there. So I am going to take here, this is one methyl group, this is CH2, so I am attaching 2 hydrogens. Here also I am attaching 2 hydrogens, and this is CH2 and this is CH2. So this I can take it as, this is 1 chlorobutane, 1 chlorobutane, 1 chlorobutane. In the next case, this is methyl group and this is also methyl group. Hope you understand in a simple lucid manner. So this is 1 2 3 4. So what I am going to do is, this is 2 chlorobutane is the IUPAC name for the second compound, second structural compound. This is because substituent is here, so 1 2 and this is 3. Okay, the longest possible chain is 3, so therefore I can just take it as 1 chloro 2 methyl propane is the IUPAC name for the given compound. And here we can just take any one side, either you can go from here, or you can come from here, or you can come from here. So I am coming from here, 1 2 3. So what I am doing is, on the second carbon there are 2 substituents. On the second carbon, methyl group, and this is also methyl group. But if you are selecting this as the longest chain, then this is going to become the substituent, and this is also going to become the substituent. So I can just take 2 chloro 2-methyl propane, 2-chloro-2-methyl propane. Here you can just take this as 1, 2 and 3. So this is methyl group and this is also methyl group. So you can just take this as if this is the longest chain, then this is going to become the substituent. This is also substituent. So I can just take this as 1-chloro, 2-methyl propane. This is the IUPAC name. So one thing what you are noticing is, see, when we are trying to decide the positional isomers, what we have to understand here is whatever the structure you are trying to get from this bond line representation, there should not be any overlapping of the IUPAC names. Every IUPAC name should be different from the other, and you can very easily track out. For example, 1 and 2 are definitely positional isomers because in the first structure the chloro group is on the first carbon, and in the second structure the chloro group is on the second carbon. Again if you take the first if you compare 2 with 3, yes, again we are going to get one chloro group on the first carbon and 2 chloro group on the second carbon. 2 and 3 are positional isomers, 1 and 3 are 1 and 3 I can say that they are chain isomers. 1 and 3 are chain isomers and 2 and 3 are positional isomers. And again 2 and 4, yes, because both of them they are having the same structures here. Again they are the chain isomers. And if you compare 4 and 5, yeah, because here the chloro group is in the second position and here the chloro group is in the first position. So that means we can very clearly say that isomeric, I can say that here isomeric, positional and chain. I am using one more word here because in these structures we are able to find both positional isomers as well as the chain isomers. So that means here if you take one with respect to 2, are definitely 1, 2 are definitely positional isomers. Again 1 with respect to 2 are positional isomers, and 1 with respect to 3, 1, 3 are chain isomers. They are chain isomers because the position of the chloro group is not changing. Here the chloro group is in the first position, here the chloro group is in the second position. In the 1 and 3 structures you can find a branch. In the third structure you are finding a branch, but in the first structure there is no branch. That's why we can outright say that 1, 3 are chain isomers. Again, if you compare 1 with respect to 4, yes, definitely 1, 4 are positional isomers. One, 4 are positional isomers. Similarly, 1 if you compare with 5, again you are finding that here 1 if you compare with 5, you are finding that here actually 3 and 5 are almost same. So what I am going to do is this fifth one, we will try for the new case. Fifth one, I think we can go like this. Yeah, tertiary carbon. So this is methyl group, and this is methyl group. So what the best thing what we can do is, I think that also we have completed it. Yeah, here we got this is also methyl group. Okay, no problem. So here if you take this structure and this structure, both mean the same here. This and this both are almost same. So this is tertiary butyl chloride, and so if that is the case, that means if I compare 1 with 4, again they are positional isomers. 1 and 4 are positional isomers, already we have done. Similarly 2 and 4 if you compare, in 2 the chloro group is in the second position, and 4 also the chloro group is in the second position, and here you can just say they are again chain isomers. 2, 4 are chain isomers. So on and so forth. So like this we can compare them with both chain isomers as well as positional isomers in the given examples.